This is Algebra 2 with Trig, section 13.4. We are evaluating inverse trigonometric functions. Inverse trigonometric functions allow us to find the value of an angle, theta corresponding to the trig value. Since many angle measures have the same trig value, we have to restrict the domain. What that means is, since there's multiple spots that have an x value of root 2 over 2, that would be in the first quadrant and in the fourth quadrant. Or, for example, a y value of a half. That could happen in the first quadrant or the second quadrant. We restrict the domain to give us a unique angle. So here, when you look at just the sine values, we have the positive sign, we have the negative sign. Sine is also negative in the third quadrant, but for the two quadrants to be right next to each other, we use the first and the fourth. So whenever you're looking for answers, we're only going to give answers from the first and fourth, unless it asks for a specific quadrant. Now, what's a little unique about here is that they're asking us for angles between negative 90 and 90. They don't want us to call this fourth quadrant 300 degrees. They want us to use it from the x-axis coming down or the x-axis going up. Cosine uses the first and second quadrant. The third quadrant is also negative for cosine. The first quadrant is obviously positive. The second quadrant is negative. So we call that from 0 up to 180 up to pi. And tangent's obviously positive in the first, negative in the fourth. One of the reasons why we might not use the second quadrant for tangent is because it's not continuous throughout the two quadrants. It's undefined here on the y-axis, so we wouldn't use it going all the way through the second quadrant. So just like sine, we'll get answers in the first and fourth quadrant, and we will use negative angles to represent our fourth quadrant. So let's talk about how this works. So this says sine inverse. When you see that little -1 sine inverse, that's indicating that you're looking for an angle value. What is the angle? What is the angle where sine is -1? Well, either in your mind or on a piece of paper, you need to draw it out and represent where is sine -1. There's only one spot where sine is -1, and that's down here. Remember, your coordinates represent cosine sine. So this is the only spot where you get a y value of -1. So you could point straight down. Now, this is sine, so that told us up here that we're going to look for values in the first quadrant or the fourth quadrant. We have to use angle values that are -90 up to 90, or negative pi over 2 up to pi over 2. We don't call that 270 degrees. So sine inverse of -1, that equals -90 degrees, or you could call it sine inverse of -1 equals negative pi over 2. That would be your radian, that would be your degree. For cosine to equal negative root 2 over 2, if you know your unit circle well, you know root 2 over 2 represents the 45 degrees. Negative cosine, those are your x values, so you know that it's going this way, or you might even recognize that it goes that way. Now cosine, we use only these top two quadrants. Looking up at our notes, when we do inverse of cosine, we're looking for our values in quadrant 1 or quadrant 2. So we don't want to consider this answer over here in quadrant 3. It's not specifically asking for that, so that implies that we're looking for the first or second quadrant. So these coordinates here are negative root 2 over 2, positive root 2 over 2. So where is cosine inverse? Negative root 2 over 2, that happens at 135 degrees. Or you could say that cosine inverse of negative root 2 over 2 equaled 3 pi over 4. 1/4, 2/4, 3/4. Now we're looking for tangent inverse of root 3 over 3. Well, root 3 over 3, notice that it's a positive value, so you know that for a tangent to be positive, it would have to be in the first quadrant, really the first or third, but when we do inverses, we're not looking in the third quadrant, we're only looking in the first or the first or fourth for a tangent. Now we know that 45 would give us a 1 because it would have been root 2 over 2 and root 2 over 2. When you divide those two, you get a value of 1. So that's clearly not it. So now I have to consider, is it 30 degrees or is it 60 degrees? Let's look at 30 degrees first. So that's a long way over and a short way up. Long way over, root 3 over 2, and a short way up. So we're going to take those coordinates. Now, we know what the cosine is, we know what the sine is for 30 degrees. To figure out what the tangent is, we do the sine divided by the cosine. And to handle that, we multiply by the reciprocal of the denominator. That gives us root 3 over 3. So, did we find the angle that has a tangent of root 3 over 3? And the answer is yes. So, tangent inverse. So, what is the angle that has a tangent of root 3 over 3? And we got 30 degrees. Or you could say tangent inverse of root 3 over 3 equals pi over 6. Let me show you what happens at 60 degrees. At 60 degrees, we have the coordinates, you're over a little and up a lot. So over a little, up a lot. So you'd say root 3 over 2 over 1/2, root 3 over 2, 2 over 1, which would give you the square root of 3. Notice how square root of 3 is different than square root of 3 divided by 3. This one was at 30 degrees. So that indicates that we were not at 60, we were truly at 30. We got 30 because we took the sine divided by the cosine, multiplied by the reciprocal, and we did get the root 3 over 3. Now, here are some notes we've talked about before. These are some different ways to look at a reference angle. When you're in the second quadrant, you can take your 180 degrees and subtract the angle that you're given. You can do it in radians by taking pi minus your angle. You can talk about the third quadrant or the fourth quadrant and calculate what that reference angle would be. Reference angle. I wouldn't stress too much about those formulas. I think the geometry portion of it we can discuss rather than trying to memorize more formulas. Okay, what we're looking for a cosine that is positive. It's 0.4, and that 0.4 is not part of the unit circle. So we're going to be using our calculator to help us calculate this. Also, they want us to give a final answer that is in this fourth quadrant from 270 to 360. That's in our fourth quadrant. Typically, cosine is always calculated in the first or second quadrant. If it's positive, it would be the first. The other quadrant that happens to be positive is the fourth. So it makes sense that they're asking for it there. But if they didn't ask, then we would have given it to them in the first quadrant. We're going to have to look there anyway, and then we'll calculate for a final answer for how that would affect us in the fourth quadrant. So let's make a sketch so we understand what's happening. If this is halfway, 0.5, 0.4 is going to be a little short of that. So we're going to go up, and we can also go down. Going up gives us an angle, and for us to figure out what that angle is, we'll take our calculator. Be sure you're in degree mode because we're calculating with degrees. We're going to say second cosine, so we have cosine inverse of 0.4. You should use parentheses. And that gives us an angle of 66.42. Cosine inverse of 0.4 is 66.42, and those are degrees. Now that is our angle right there. Now that's considered our reference angle. So we're going to take that 66.42, and we're also going to, instead of going up the x-axis, we're going to go down from the x-axis. So that's also the value there. So how are we going to calculate? We need a final answer that is between 270 and 360. We want to be sure that our calculations are coming from our x-axis. So for us to get to that x-axis, we need to come a full 360 minus this 66.42. So we'll take our 360 minus the 66.42, and $360 minus our answer would give us 293.58. That would be the other location where the x value is over 0.4. And we go up and we have that, we go down and we have that. Next we have tangent. Now we're looking for where tangent is 2.1. Well, we know that happens somewhere in the first quadrant. Well, they're asking us for an answer in from 180 down to 270. They're asking us for the angle in the third quadrant. That's the other location where tangent is positive. They can't ask us for a positive tangent where tangent's negative. That doesn't make sense. They have to ask us for it where it's positive. So we're going to first figure out where that's located. Tangent 2.1 is not part of our unit circle. So we're going to say tangent inverse of 2.1. That gives us 64/54. Those are in degrees. So that's the angle that's built off this x-axis. Now we also want to come into the well, we're going to come off the x-axis into this quadrant that same amount. 64/54. That's called a reference angle. If this angle is what it took it to become 2.1 for tangent, then coming into our third quadrant will also be 64/54. So now, what are we going to do to figure out that value? We're not going to say 360 minus 64, because that would be over here in the fourth. We never measure off the y-axis, so we're not going to say 270. We're going to say 180 plus an extra amount. So 180 plus 64/54 is 244/54. Looking up at this chart, just so you understand how the chart here works. Well, I was hoping this was going to make a little bit more sense to me. This is theta minus our angle. Our theta was 64, so again, this isn't making a ton of sense that way. I think that you should know it from the geometry point of view, that if you come over to your x-axis and you're going down, you're going an additional amount of 64, then you're adding it to 180. On the back side, we're looking for a sine value at negative 0.23. Now, that's not the value, that's not a degree, that's the value of sine. So that's your y value, negative 0.3. So sine, typically we know, is in your first quadrant or fourth quadrant. Negative sine is going to be down this way. So we'll use our calculator to help indicate what that is, because these values are not part of our unit circle. So sine inverse of negative 0.23 gives us an answer of negative 13.30. So that would be this angle right here. That's the spot where sine is negative 0.23. The value of the y would be down 0.23. Now, if we're supposed to give a final answer that is between 270 and 360, how can we figure out what that value would be? Well, it would be the full 360, not counting this 13.3. So 360 minus 13.30 would give us 156, or actually 346, sorry. Oh, it was negative, so two negatives make a positive. That was confusing. Let me start over with that one. 360 minus 13.30 gives us 346.70. So that would be our actual value of sine. That is a negative 0.23. The angle that's between 270 and 360 would be 346.70. Let's look at cosine. Where is cosine 3/4? Again, 3/4 is not a spot on our unit circle. Where is the x value 3/4? If this is our half, 3/4 would be another halfway between there. So we're looking to be up there somewhere. Looks pretty close to 45, but I'm pretty sure it's not going to quite be that. So we're going to look at the cosine inverse of 3/4. Cosine inverse of 3 divided by 4, or you could put 0.75, and that comes out to 41. So it was pretty close to 45. It's just a sketch. My sketch might make it look a little bit over. It's really a little bit under. But we want a final answer. Remember, cosine is your x values, and x is positive when you move to the right. So the other quadrant is positive to the right is down here in the 4th quadrant, and that happens to be where they're looking. So we need this value really in the 4th quadrant. So how are we going to figure out what angle is going to be between 270 and 360? That matches a cosine of 3/4. That matches where we have this line drawn. Well, 360 minus the 41. 360 minus 41.41 gives us 318.59. And those are in degrees. Now we're looking at a few questions very similar to what we would have done in geometry class. We have a triangle. We have theta, so they tell us what angle that we're looking at it from. We have a right triangle, so we can use SOHCAHTOA. When we look here, we have our theta. Across from theta would be considered our opposite side. Next to our theta is our adjacent side, and across from the 90 is always our hypotenuse. So if we're going to use SOHCAHTOA, we're looking at the adjacent over hypotenuse. Adjacent over hypotenuse is cosine. So cosine of our theta is supposed to be 4/9. To figure out what angle that makes. Now notice that if this is a right triangle, there's only one possible way that you could make an adjacent side to be 4 and the hypotenuse to be 9. That's why we can calculate what that angle is. There's only one possibility that could work out. So cosine inverse of 4/9. We use our calculator. Be sure you're in degree mode. Cosine inverse of adjacent over hypotenuse gives us 63/61. So that's what our angle of our right triangle would have to be, 63/61. Next, we're looking at letter B. What information, what side would 10 be considered? What side would the 8 be considered? The 10 is across from your theta, so that's called your opposite. The 8 is the other leg, so it's considered your adjacent. Across from the 90 is your hypotenuse. So which trig function would we use? Opposite over adjacent. Tangent of our theta is the opposite side over the adjacent. So we're going to say tangent inverse of 10 over 8 to help us figure out what that actual angle is. Tangent inverse of 10 divided by 8 comes out to be 51/34. And then last, over here, we're looking at a right triangle. If this is our theta, we go across from it to see our opposite side. Next to that, the leg next to that angle is considered your adjacent. Across from the 90 is considered your hypotenuse. So you're looking at numbers that deal with the opposite side and the hypotenuse side. So SOHCAHTOA tells us that opposite over hypotenuse is sine. So we're going to use sine of theta, which equals opposite over hypotenuse, 5 over 12. So to figure that out, we do sine inverse of 5/12. And our calculator will help us do that. Sine inverse of 5 divided by 12 gives us 24/62. Now, of course, we're looking for acute angles here. So all of our angle measures that we're looking at are always in the first quadrant. If we're working with a typical right triangle in SOHCAHTOA, all of our answers are coming from the first quadrant. So we don't have to worry about converting or subtracting or anything crazy like that. It's just what we have in our triangle, all part of the first quadrant. 2 word problems. If a building is 52 feet tall, so we have a building here. There's all the windows on our building. That is 52 feet tall. It casts a shadow down. So here's the shadow. It's a 23-foot shadow. We're supposed to find the angle of elevation. Well, the angle of elevation is that with your horizontal and the ground, looking up at the top of the item. So that's your angle of elevation. Across from that would be considered the opposite side. Next to that is considered your adjacent side. Across from the building that's standing at a 90-degree angle, that would be considered the hypotenuse. So which trig function are we going to use if we're working with the numbers 52 and 23? That is tangent theta equals opposite over adjacent. So we don't need to cross multiply and solve because we know all the sides. What we're looking for is the angle measure. What angle measure makes a right triangle have an opposite side of 52 and an adjacent leg of 23? There's only one possible solution. So we'll do tangent inverse. You take your calculator. Tangent inverse of 52 divided by 23 comes out to be 66/14. Those are in degrees. Last one. A monster truck drives off a ramp in order to jump a row of cars. So there's our ramp, and then we have all of these cars that are going to be stacked up. Alright, we'll put our wheels on the cars. Alright, maybe the hoods. Yeah, those look like cars, alright. Okay, so our monster truck is going to drive up this ramp and jump way over those cars. So, the ramp has a height of 10 feet. So we're 10 feet high. The truck drives 26 feet on the ramp. So the ramp is considered to be 26 feet long. Before it jumps the row of cars. What is the angle of the ramp? Here is the angle that we're talking about. This is our theta. So which trig function are we going to use? The 10 is on the other side from this angle, so it's called the opposite. The 26 is across from the 90, so it's called the hypotenuse. So that's going to be sine of theta. Sine of theta equals 10 over 26. So to figure out what the angle is, sine inverse of 10 over 26 we get 2262. That would be the angle that would be needed to have one side, this opposite side at 10, and the length at 26. The only way to make that happen is to have a 22.62 degree angle. If that was any more, then you would need a larger than 10. If it was any less, then you'd need less than 10. There's only one possible way to get a 26 and a 10 to fit in here, and that's to have an angle exactly 22.62.